Welcome back to Air Quality Matters. We already have the tools and knowledge we need to make a difference to the quality of the air we breathe in our built environment. The conversations we have and how we share what we know is the key to our success. I'm Simon Jones, and coming up, a conversation with Jelle Laverge, Gaelle Guyot and Mark Abadie on Annex 86, on energy efficient indoor air quality management in residential buildings. The last 5 years or more, dozens of domain experts and academics from all over the world have been coming together to work on an international collaboration to create an integrated general assessment method to operationalize the development, rating, and implementation of innovative and highly energy efficient indoor air quality management strategies. As this annex, part of the International Energy Agency's Energy in Buildings and Communities, moves into its reporting phase, I took the opportunity to sit down with Jelle, the overall operating agent for the annex, and Gael and Mark, two of the task leaders, to talk about some of the outcomes. Annex 86 is a fascinating dive into indoor air quality metrics, source characterization and exposure, smart materials, and the performance of smart ventilation. It's an incredible collaboration of minds at the cutting edge that is already having impacts on standards and thinking around the world, and a great introduction into the work of the IEA EBC, that's the Energy in Buildings and Communities, Annexes, and how they feed into it. Don't forget to check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Jelle Laverge, Gaelle Guyot, and Mark Abadie. So I suppose for listeners that aren't completely buried in the International Energy Agency, most people won't really have a concept of what an annex is at its core. Let's perhaps start there, because today's conversation is mostly around Annex 86. Perhaps start with the basics, Jelle. What is an annex and who is it for?
You're absolutely right that many people will not directly know what it is, because even within EBC and IEA, there's some confusion about the term annex, in a sense that it's a name for a big group of researchers from a bunch of international institutes that want to work together on an energy in buildings and communities related topic, and then write a kind of proposal for that, and then set up a collaboration that lasts for 5 years. That's the short brief of what it is. The name itself is a bit unclear. From what I've heard, it's actually a technical name for the fact that so the EBC, which is a technical and collaboration platform within the large umbrella of the IEA, so the International Energy Agency, they have like working groups on specific topics. One of them is energy in buildings and communities, so that's EBC. They have sort of a contract with the IEA, and if they want to set up these temporary research collaborations, there was a technical reason that needed to be written in an annex to the original contract. And so that's where the name annex comes from.
Okay, and interesting.
In other TCPs, they're not called annexes. For example, they're called tasks or working groups or whatever. So, but yeah, the name somehow stuck, so everybody calls it an annex. But so basically, it's an international collaboration.
Yeah, it's for one of in kind of plain English, it's a project for a defined period of time.
Yes.
Under the umbrella, under the executive committee of the EBC. So there's a series of them, and I guess the clue's in the name, Annex 86. This is the 86th annex or project under the EBC.
That's correct.
Yeah.
So there used to be just one or two running. at the same time. But nowadays there's typically like 5 or 6 or even 7 going on at the same time.
Interesting. And how long do they run for typically? I mean, when we say, they're quite big collaborations, we'll come on to that, but it's not something you set up for 6 months and you're done, is it?
Goes through kind of a extensive setting up process. It has to be approved also by the EBC, which has representatives from all of the member countries. So there's a big formal process before you start. And then a typical annex lasts for 5 years. The first year is a preparation year, so where you try to make sure that all of the institutes that are interested know what they're going to do, get their funding in place, things like that. Then there's a 3-year working phase where you do the actual work. There's a 1-year reporting phase. And for Annex 86, we're now in the reporting phase. So we're in the concluding last year of the project.
And what is it? And do they differ from annex to annex? So it's a collection of people, how big a venture is pulling an annex together, in the sense that this is something that runs for 5 years. It's not a small thing.
It's not a direct answer to the question. I was more thinking about the fact that it is 5 years for one annex, but very often we have one annex before or one annex after who was strong links between the current annex, which is the case for Annex 86. We had before the Annex 68. And then at the end of this project, we identified the needs and the needs were more clear at the end of the Annex 68. And then we proposed the Annex 86. And now that we are at the end of the Annex 86, we are thinking about the perspectives and what could be done now, and it would be, we hope so, we will have another annex. So it's not the direct answer to your question, but I was thinking to that point, that's 5 years already, it's a long period, but in fact, it could be collaboration over more than 10 years. It's not exactly the same topic, it's not the same project, it's not the same institutions, but there is some key persons maybe, or key issues like ventilation, energy efficient building, which stay in the heart of those projects.
Yeah, you can understand that in the built environment. I mean, there are running themes, aren't there, through buildings that I guess don't get answered in 5 years ultimately. And like all good academic endeavors, inevitably there's further research required at the end of it.
Maybe that's an interesting thing to talk about, because annexes are not specifically academic, so they're within the umbrella of the International Energy Agency. So the goal is always to lead to practical results that can serve the member countries to address some of the pressing issues in the built environment, in the case of the EBC.
Okay, interesting. And can it be a two-way thing? Can you find that you're getting asks downstream as well? So they're saying, yes, that's great, but actually we think we'd like to understand this as well. And did you see that in Annex 86, where there was feedback from the theme of 68? You said, look, we think we need to do this. And they said, yes, that's great, but actually we'd like this looked at as well.
Yes, definitely. So every 6 months, there's a reporting on how things are going. So you present this and this and this we've done. This is what we're thinking about. And then there's some feedback, and some of it is really helpful. For example, there's representatives from all of the member countries, and during Annex 86, at some points we got feedback that, okay, this country is working on this type of rating scheme, for example. We can bring you into contact with the person in that country that is doing that, or this group is doing research where they're doing measurements that may be relevant, or they have data that is relevant. And similarly, if they have policy developments going on, that they would ask like, okay, can you maybe give us some feedback, or can we make sure that you include this aspect in the project?
Interesting. So it has to ultimately produce something. I mean, that there's a goal to the annex in a report. I guess that's why we're in the reporting phase. Ultimately, it has to come up with something substantive. There's a mission to come up with something substantive that's useful. Even if it has some further questions, the goal is to come up with something that's.
And this is what differentiates it from other initiatives from the IEA or the EBC, that it has a fixed goal. So in the beginning, you define what the deliverables are going to be. It's really, like you said, like a project. So you work towards some goals that fit the ambitions and the desires of the people represented in the EBC. And if they approve, then that's what you go for.
Okay. And what does it look like on the ground? I mean, how many people are involved in the annex broadly? Is there like a core team of people that are working on certain subjects and a broader group that support them? I mean, how big a venture is it in totality?
Go ahead. So in Annex 86, got to make sure that I don't screw it up, but I think there's 46 institutes represented from 21 countries.
Wow.
Involved at different levels of involvement. So the idea is that every 6 months we come together, we discuss the progress. Every country sends representatives, and they then make sure that they coordinate with the other people involved in the country. And for every one of the goals or deliverables that were discussed or proposed in the annex, they're organized in tasks or subtasks, they're called, and then the specific people, 2 of them who are here with us, who coordinate that specific part of the work, so that they're more involved and do some coordination work with the rest.
Brilliant. That's probably a great segue to introduce everybody, for those who aren't familiar with Jelle, Gael and Mark. Perhaps start with you, Gael. Who are you? Who do you work for? And what's your involvement been in the annex?
So I am Gaelle Guyot I work at CEREMA, which is a public institute in France, under the supervision of the French Ministry for Ecology. And so in CEREMA, we have some teams involved in the regulations, current regulations, but future regulation as well, in national and European standards. And we have some research teams, like my research team, where we traditionally perform research activities, including such projects. And so I am involved in research activities on ventilation, air tightness, and indoor air quality in buildings. I have been involved for nearly 16 years or something like that.
So how does somebody involved in a research institute or organization like CEREMA end up involved in an annex? Is it something that you're aware of as part of your general work and you find out and apply, or how does that work? How does somebody in an organization involved in research end up working on a project in an annex?
In general, I cannot answer to this question. In general, I would say it depends on the situation. Some of us are already working together for a while, and so maybe in former annexes, I was involved, but not so much than in this one. And then it depends on the topic as well. So I started working on smart ventilation quite long time ago now. So when this topic come on the top of among the hot topics in the Annex 86, so it was maybe an evidence for Jelle to contact me. I don't know exactly, but yeah, it was like that. But there is as well a question of availability, because it's quite time consuming. So we have to be sure that we have resources and people in the team, but financial support as well for this long period of 5 years, and that we will be able to conduct the management activities. So yeah, it's a combination of different factors.
Yeah, that's a good point, actually, and a question I meant to ask. I mean, how does something like this get paid for? I mean, you've just talked about dozens and dozens of people from 20 odd countries or more involved in something for 5 years. That's not that's a time resource heavy problem to fix. Like, how does something like this get financed ultimately?
So what we haven't talked about so far is the fact that the IEA and therefore also the EBC is organized around member countries. So countries, commit to being part of this organization, and as part of that commitment, they need to set up a structure internally to make sure that they have resources available to participate in the activities of this platform. And every country does it a bit differently. So some countries will have specific grants available for participation in approved annexes. Others will stimulate their local researchers or local stakeholders to participate based on their own contribution, basically. So that's depends on which country you're in. And so a big part of setting up an annex is creating the network of people who are in the field working on the specific topic, making sure that they are into participating in the annex, making sure that they are aligning the resources that they need to be able to participate. And therefore, the topic of the annex evolves over this preparation process to really fit the needs of the stakeholders, but also the possibilities and the availability of the people involved.
And you're both task leaders, so I take it you're both representing France in the task. How's that financed in France then, as an example of your time?
No, it's a bit different than before. It changed. Before we just joined the Annexes program, say it, and then we would get funded to attend at least every 6 months, just to attend travel expenses and this kind of stuff. Now we needed to find our own financial support and apply for different projects that fit with the Annex research project.
Yeah. Okay.
So it's kind of difficult. More difficult now, actually.
I think in general we can say that people involved in the annexes, they don't have very huge financial support to do it. Maybe some have, but not so much. So it's based as well on external contributions. Like, it's not external, but if we have a PhD student for 3 or 4 years, that we are sure that he's going to work on the topic of the annex, it's easier to become involved, to be sure that we will do the work and will succeed to have some interesting deliverables at the end.
Yeah. And so you took on a task, as you were saying, which was the smart ventilation, wasn't it, and ensuring performance part. And then Mark, you took on a task then on the source characteristics and exposure. So both of you effectively take on. So perhaps we'll come on to that in a second. So how did you find yourself involved in the annex then?
I was involved in the previous annex, the 68.
Okay.
That was about the same subject, of course. And I was more involved in part to define indicators to evaluate indoor air quality and energy also. energy is an important part of the IEA. And so the thing why I was involved in the source characterization is because at my lab, I'm from La Rochelle University. I'm a researcher there, teacher also. My main field is in air quality, of course. I'm teaching building physics, heat and mass transfers in buildings. It's the main field. And with a colleague of mine, we developed a database about this source characterization. This is why we had that for a long time. And it was an opportunity with this work of the Annex to try to update the data, to participate to the whole project, defining inputs for the modeling that the modeling is needed, so that kind of input from the source or emission of pollutant to be able to evaluate the performance of the ventilation system, the task of ST4, Subtask 4.
Yeah. And so together with Mark, we submitted a national project to the French Agency for Ecological Transition. I think this is the good the good name. I'm not completely sure. But so the idea is that you cannot just say you participate to an annex and you will have the money to do that. You have to have a French project, which is like a mirror of the Annex 86, and to have you have your own activity in the French project, but you try to make a link between the annex in order to contribute to the annex as well.
Is that quite common then within annexes, to this kind of the contribution of the tasks themselves, but then tying it in with either ongoing or new academic work within an institution or a particular subject matter within country? So there are kind of co-benefits or parallels of this work that are kind of going on. So do you see things like academic papers being written as part of the work that's being done for this? Okay.
So like Gael was saying, most countries don't have specific research money available for participation in the annex. There's a few, but it's very limited. Most countries, if they have some funding available, it's for attending the meetings. And then for the actual research, you're reliant on work that you're doing in another context, but that fits the topic. And so I think there's multiple reasons why people bother to even do this. It's because it provides a very stimulating environment, because you really have most of the researchers in the field that are working on this particular subject together every 6 months to exchange findings, to talk about what it is that is the next big challenge. And so for younger researchers, it's a huge benefit to be part of this network.
Yeah. I can imagine. We've seen that over the years, young people coming up through that network in the various different annexes. It must be perfect.
Yeah, if you're doing a PhD, that is the environment you want to be in, because all of a sudden you have access to direct access to many of the leading researchers in that field. So
you're working with the authors on the papers that you spent your student years reading virtually. I imagine. Yeah.
Or if we have different PhD students, for instance, one in a yellow team, it was what happened during the Annex 86. We had different PhD students in different institutions, but on very similar topic. And as they were working, they had some opportunity to work together during the Annex. They had some chats, some meetings, and some common exercise as well. They really, I think, were more efficient, or at the end, they go faster, or even maybe they in deeper. And so at the end, the PhD thesis is really much better, mature, and that's really good for the quality of the PhD thesis as well.
But I'm assuming at some level, the annex meeting and the 6 monthly come together is like the iceberg. It's the bit above the water the substantive work is the stuff that happens when everybody goes home again and goes away with everything that they accidentally volunteered for in the meeting for the next 6 months.
Definitely.
Yeah.
But what Gael was saying is for me really core in the sense that since most of this work is funded externally, let's say, you can maybe assume that it would also happen if the annex wasn't there, but the annex creates an opportunity to align it and to make it much more efficient, much more coherent, and therefore go much further than you would do if everybody was just doing their own research and then maybe reporting on it on a conference, and then you learn from each other much more in the distance.
So it's a real silo breaker from that perspective, that its ability to break down those barriers, because like even on the same topic, the frustration in almost all circles, isn't it? Is that the same people working on the same flipping thing, if only they just met and chatted 6 months ago, that kind of a scenario, it must make a big difference for.
And that's the context that the annex provides to avoid that.
So at a high level then, what is Annex 86? What was the seed behind the idea of energy efficient indoor air quality management in residential buildings? I think if I get that title correctly. I scribbled it down in shorthand and then realised I can't read my own. But I think I'm broadly right there. It's energy efficient indoor air quality management in residential buildings.
That's the title. Yeah.
So why? What kind of? Because at some point I remember a few years ago that idea in the first phase is being presented as a concept. What was the kind of seed behind that? What's the need that's driving that?
Well, Mark already mentioned that there was a previous annex, and Gael also, Annex 68, who looked at indoor air quality in energy efficient buildings. And so that was more like a prospective approach, where we looked at what kind of pollutants do we typically find in energy efficient buildings. Are they different from non-energy efficient buildings? What kind of physical phenomena do we need to model to be able to understand what is going on in these buildings? And at the end of the annex, it was clear that we now had a much better understanding about what was going on, but we did not have the tools necessary to then design and propose adequate solutions to improve the indoor air quality. And so that was the whole idea of this annex, and that's why it's called indoor air quality management. We didn't want to exclusively focus on one specific solution, but we wanted to create the assessment framework that is necessary to compare different solutions one to the other.
And you see that reflected then in the subtasks, I guess, that they're reflective of that need to move it on. So you have the desire to define metrics and management strategies, which is one of the tasks. If you're going to do that, to understand the sources that you're dealing with from an air quality perspective and exposure values. How do you model that and store it and research it, which is the stuff you've been doing, isn't it, Mark?
Yeah.
Smart materials that are increasingly part of our built environment and certainly will be in the future. Then the work that you were doing on ensuring performance then effectively, like, so if you're having smart systems, how do we understand how to compare them? How do we know they're working?
Smart ventilation
systems, yeah. And then a kind of an evaluation part, I guess, which is the energy and indoor air quality through kind of monitoring and an assessment part. So it kind of reads to me anyway, at least, like it's we think we understand the science part of the building, right? How do we then start characterizing the building blocks to get a good outcome? Is that a fair kind of summary of why those subtasks exist?
Yeah, I think so. That's a nice summary of the way of thinking when we were setting up the annex. So the observation was, okay, we understand and we're more or less able to characterize what is going on in a building. But now of course, most of us come from an engineering perspective, so we want to be able to propose ways of improving this indoor air quality, and that breaks down in a couple of different parts. And the first two subtasks deal with the methodology. So what are indicators, what are input data that you need to assess the performance of any kind of solution that you would like to propose. And then subtask 3 and 4 specifically zoomed in on two technologies that are available, smart materials and smart ventilation, and then identified different challenges related to each of those technologies, who are, by the way, at very different technology readiness levels. So that's also important, because we wanted to make sure that the way of thinking about how to assess performance worked for different types of technology. So not tailored specifically to smart ventilation or to smart materials, but one that could overarch and allow you to compare the performance of one technology versus the other, and therefore make an informed decision.
Yeah, interesting.
And then the last subtasking lead was about, we were really at the moment where Internet of Things was starting to take off. We were seeing implementation of much more connected devices in the type of technologies that we're studying, and we wanted to explore how this change, the sudden availability of much more data, could also inform this whole process.
Yeah, and interlinked, I'm guessing, completely with both what you two were doing as well in smart ventilation, and also sources and exposure monitoring and measuring must be a key part of that as well. So you can understand how that came about. What was your role then, Jelle? Were you part of any of these subtasks, or were you taking more of an overall responsibility across the board? Like, did you have a defined role in this, in the sense that it needed managing as a complete thing?
That basically was my role. Yeah. So at the end of the previous annex, we were sitting together with some of the people involved to discuss, like, what is the next big challenge. And I had a very
simple story, because you go to the paper board.
Yeah. I got the very stupid idea of taking a pen and writing on a blackboard.
Exactly.
This is more or less how it could work.
Exactly.
And by default, I was now responsible for making it happen. So
You was elected.
Yeah. It's one of those. It's a classic. Those environments. You have an idea and then immediately regret having the idea. So you've been basically the overall annex manager.
yes,
Overseeing
the operating agent is the official
name.
But
so your responsibility is to bring all this together ultimately and present the report effectively.
Yeah, make sure
the end. Yeah,
everybody does what they promise to do and try to keep people in line.
Yeah,
which sounds much more stringent than it actually is, because it's people interested in the topic trying to contribute. So it's.
And has your sense been with this annex that it's been a clear evolution from the previous one? There's been a step change in what you've looked at and the kind of things and results that you're seeing. It reads a little bit like the People's Front of Judea and the Judea's People Front, Annex 86 and 68. But actually, when you scratch at the surface, you realise it seems to me like a very clear evolution into the art of the possible.
Yeah,
I suppose.
Yeah. So like I said, the previous one was more exploring, like, what do we find in energy efficient buildings? Well, this one was much more oriented towards being able to provide solutions to design. So we also worked, for example, on input for a number of standards where we're trying to move the needle towards the type of methods that we developed.
Yeah,
in the annex.
So let's get into some of the detail then, because I mean they're fascinating subtasks, and I mean, no, we couldn't. I don't have enough microphones to have everybody here talking about it. Plus, some have gone home already. But so subtask 1 was really about metrics and management strategy. So this was defining what good looks like, effectively, to some degree, like putting some lines in the sand somehow, somewhere.
And especially trying to come up with metrics that allow you to trade off different indicators, because one of the outcomes, and Mark is actually a pretty good person to talk about this, one of the outcomes of Annex 68 was that we had a whole list of indicators, bunch of pollutants, where for each pollutant we would have a reference level. But then if you're trying to design different systems, and one will perform a little bit better on this indicator and the other a little bit better on the other indicator, and so here the quest really was to come up with indicators that allow you to comprehensively assess the performance.
Okay.
Exactly. Yeah. The problem is what we call the problem of aggregation of indicators. When you have multiple indicators, what do you do?
Yeah.
To make sense for you to have just one number or two maybe sometimes, but it's to make that, and that's what has been done during the first subtask here.
And I think for listeners of the podcast, if you go right back to Max and to Ben Jones, so Max Sherman and Ben Jones, very early on, both spoke at length about, I guess, some of that topic, about where they started to develop harm metrics and start to think about this idea that some pollutants may be present but not so harmful, but some presents may be less present but more harmful, and so on and so forth. How do you actually bring all of that together in a meaningful way to say, okay, what's important? So that was subtask 1. It was that kind of trying to frame and define what good or bad or indifferent look like in some way.
Yeah, the IAQ thermometer.
Yeah. And has that been, you've been happy with that work? I mean, that's been a successful,
absolutely
in depth.
And we learned this morning that the ASHRAE 62.2 standards has voted this week that they would use. So we don't know exactly, but the work done during the Annex 86 was a basis for a revision of the. It's an American standard, the ASHRAE 62.2 on residential ventilation.
So it shows this work is relevant, that even before work is completed at a whole from the Annex, the work in the background is producing good output that people are paying attention to. Yeah.
And it's Max and Ben who were pushing this all the way through, and really, this is what I said, we try to add a dimension in this annex where we try to go all the way to close to implementation. And this is an example where they were able to put it on the agenda in the ASHRAE committees, push it all the way through, and now will be implemented in the standard.
So I guess that's the kind of thing that's seen as a win by the EBC, that work that's being done has practical application in standards or regulations or in research or whatever it is.
Definitely.
Yeah, okay.
And we're on the same track on the European level, where about a number of us are trying to implement the same type of reasoning in European standards as well. But that effort is still ongoing, but there's good hope that we will be on the same track.
While I have you, I just want to borrow your attention for a minute to tell you about Erico, a partner of this podcast. In fact, I worked for Erico for over 12 years, so I can speak with some authority here. With over 40 years of expertise, Erico has undoubtedly established itself as a market leader in DCV technology. That's demand-controlled ventilation. Their mechanical extract systems dynamically adjust airflow rates based on real-time needs, and their MVHR systems further enhance energy savings by recovering heat while delivering fresh, filtered air, both creating comfortable and sustainable environments. Their advanced solutions are tailored for residential, commercial, and educational settings, ensuring optimal indoor air quality and energy efficiency. As part of the Aldis Group and based in Paris, France, Erico continues to innovate and set benchmarks for the industry. Their solutions seamlessly integrate into buildings, providing intelligent, efficient, and reliable ventilation tailored to the unique demands of each space. With a global footprint, Erico, as part of the Aldis Group, are a powerful partner in securing good indoor environments and are well worth checking out. Links are in the show notes at airqualitymatters.net and, of course, at Erico, spelt aereco.co.uk. Now, back to the show.
And I suppose you can define what good looks like or bad looks like, or where these lines or parameters sit, but at some point you've got to figure out what's there. How do I research it? Where's it stored? What are the database? And that's where you came in, Mark. And Subtask 2 was this, okay, what are we actually talking about? Where's the evidence for it? How do I bring all of that together? Explain maybe a little bit about the kind of the goals of Subtask 2.
Yeah, when you want to model something, a pollutant concentration of some kind, you need indoors. I mean, you have some what comes from outside, from by the air, ventilation and infiltration, and you have one of the important thing is the sources, the indoor sources, like this table, for example, and we need some data about the emission of this. So in this subtask, this table, the materials, the different reactivity of the occupants, there's a lot of indoor sources like that. And the way we worked on this annex is two sense, like we call the bottom up or the top down approach, two approaches. The bottom up is really to have some data about this table in particular, how you measure it. And there's a lot of data in the literature, in the scientific literature, but it's all over the place.
Yeah.
So the idea was to take all of what we found interesting for our problem and to put it in the same place in the database that is called Pandora.
Okay, so unpack that a little bit for me. So the bottom-up approach is this: what do we actually know about the sources in the building? What evidence? What is
we
it?
have measured in laboratory under certain circumstances, controlled circumstances, environment, temperature, and this kind of stuff.
Okay.
So we have a way to measure the emission of that.
So there, that must be a massive list of both materials and pollutants.
Yeah.
Yeah.
For each material, we can have several pollutants.
Oh, sure.
Thousands of pollutants.
Yeah.
Which is called VOCs, in particular for stable, if we stay on this table. But we have also a lot of things about particles, which is very important for health effects.
Let's come back. I want to come back to particles actually, because I think that's probably important. But so this bottom up approach is there's a lot of information out there, isn't there? Both from product suppliers about and product labels and sources of pollutants from formaldehyde, for like you say, from tables and so on.
Yeah.
So it's about So is this someone that wants to do modeling or research can have a place to go to where all of this is kind of pulled together in a way that they can make some decisions over what they think.
And this is the objective of this database.
Yeah. Okay. Interesting. And on the particles thing, then, is that the particles that certain sources are producing?
Yeah. Or
is that trying to define where the sources are coming from the particles that are in the space already, sort of thing? Do you know what I mean? Like, are you looking at the particle production from cooking activities,
exactly.
for example?
That's what we are doing.
Yeah, okay.
Yeah, to have the measure of that. Most of the time it's burning something inside the house.
So I mean, naively, I assumed that would already exist. That with all the research that's going on, and I guess there is lots of
Yeah, but
information.
like you said, there's a lot of sources, different sources. Each source is a particular source. That's the main problem. So by accumulating all this data, we're able to look at some statistics to say, okay, the range of emission will be between this number and this number, and we can play with it in the simulation after that, in the modeling part.
So the power is like kind of bringing all of that together in one place, so you can actually. The great thing about modeling is change certain characteristics or have a look at what the impacts of all that is. Understand, so you can make some informed choices rather than having to just go by a particular paper's outcome. You've got it all in one place that you can manipulate it and see what it. Okay, really interesting.
And also to give you like a range of uncertainty on the things that you haven't measured. Mark was pointing at this table. It's unlikely that there's a measurement for this particular table available. But in the database, you can now look up tables with similar characteristics or tables and give you a range of, okay, it's probably within this range.
Yeah.
Use that for your modeling.
I think anybody that's done kind of LCAs and that kind of thing is well used to that kind of, does my product exist? No. Is there something like it? No. What's the default one? Does it have wood in it? You kind of go down the scale of preciseness, don't you, until you get something that's as close as you can to equivalent.
So in the database, you can really take these approaches. Find your own, exactly the one you have sometimes, but most of the time you don't have, so you will have some range of emissions.
And is this the first time something like this has been done, do you think? Like, because I imagine in certain fields you'll have databases of materials, but I imagine you've got quite a broad set that you're bringing together. Is it?
Yeah, when we created this database in 2009 at my laboratory in France, there was already existing database about only materials emission, wallpapers, paint, most are paint. Carpet, this kind of thing. So we took actually all this information already into this new database, because the problem with database is the maintenance.
Most people manage data
alive.
Yeah.
Keep it alive. It's a problem.
And stuff goes out of date or stuff gets refreshed and
exactly. And for me, the occasion of this annex was to update part of the data, because we stopped implementing new data in 2014 and something like that.
Okay.
And there was a lot of new study that evaluated emission rates from different sources. So we implemented a lot of new data now.
Okay.
Control.
So that's the bottom up.
Yeah.
You were saying there's also another...
The top down.
Yeah, what's that then?
So here it's connected to what Jelle told about. It mean that now that we have to measure some pollutant in a real-time, almost a real-time manner. And we started to have a lot of data now. Every 10 minutes, for example, if you just talk about CO2, for example, that after COVID now, we have plenty of measurement of that in schools or in residential building also. And we have some data for different, sometimes it's several years with a very short time step. And the idea is to use this whole bunch of data to identify some parameters of the building where they are measured, and to define, to evaluate the sources of PM 2.5, for example, or formaldehyde that we've done this project.
So you can see instantly how Subtask 1 feeds into Subtask 2, because I guess Subtask 1 says, right, okay, there's 180 pollutants of interest that might be in a building. Can we zero that down into something manageable, set a frame around it? That then from a top-down approach says, okay, let's go after that data and have a look and see what we're actually measuring. So from Ben's work, things like particulate matter and formaldehyde and
the main ones,
NO2 and so on. You can then go, right, okay, where's the data, and bring that into a database as well. So does the top down and the bottom up kind of talk to each other in some way? Are you kind of
you try
meshing
to
in the
do
middle?
that. It
Yeah.
depends on the way you calculate, like you use this data. But we make an example for a bedroom. We had some very precise measurement of formaldehyde, which is not so usual for a long time. I mean, and it fit pretty well with what we have from the Pandora database and from the top down. Sorry.
I mean, and the thing that strikes me in all of this is that with the timescales that you're talking about, kind of 5 and 6 year periods, the technology is moving on really rapidly, and our understanding's moving on really rapidly, and we do things like throw a pandemic in the middle as well, and all of a sudden it's quite a dynamic environment. You're pulling these big ideas together, and all of a sudden half a decade slips by, and what you started thinking about 5-6 years ago, the horizon can change, I guess, quite dramatically in some cases.
Absolutely.
Yeah.
That was one of the reasons to include, for example, this subtask about what is going on with IoT sensors.
Yeah.
Because that was just peeking over the horizon at that point, and we really wanted to see it.
You were probably a couple of years too early, I'd say, almost with that one.
Maybe.
You know, like if you're asking that question again now, it'd probably be a different horizon again. Yeah. Really interesting.
Although I also see that some of the enthusiasm that manufacturers were having in the beginning for implementing these devices has waned a bit, because they understand that it comes with a whole suite of quality insurance and things like that.
Yeah. And you get pesky academics looking in on it going, that's junk.
For example.
Yeah. Tell me how smart materials, which is the third subtask, kind of meshes in with the annex in general. I mean, I've sat in a couple of the meetings, and it's certainly well outside of my comfort zone, I have to say. Like, there's a lot of chemistry going on. So you note, I asterisk next to you said that you're all engineers. So I can imagine even for you that they're slightly different equations you're looking at with the building with smart materials. But it is relevant, isn't it? Nonetheless, I mean, it is an anathema in a lot of ways to the stuff that we're used to, but it's increasingly going to be part of our built environment, I guess.
Yes. So also this is something that you see that is coming onto the scene in fits in bobs, but really what it's about is we're now able, other people, the chemists are able to engineer materials so that they have specific properties that are relevant in the indoor environment, and particularly to deal with indoor air. And so one of the materials that the group in Subtask 3 focused on are metal organic frameworks, which are MOFs.
Yes. That's one I picked up. Seems like a really interesting thing.
Try to explain it very succinctly what it is. It's a material that's engineered in such a way that it has a huge absorption capacity for very specific pollutants. And so they looked at MOFs that were developed to absorb formaldehyde. And so basically that gives you a virtually endless sink of formaldehyde in your space. And they also engineered it in such a way that it has the property that it's easy to regenerate. So when it's absorbed all of this formaldehyde, you can remove it again from this material in relatively mundane conditions. So slightly higher temperature, basically just washing it.
Yes, it sounds almost magical, to be honest. Some of this stuff, like typical chemistry, you know, that kind of stuff, changing color and changing form in front of you, chemist stuff. But it is like that. It's an amazing absorption for these pollutants, and literally sticking it in a bathtub of water, and hey presto, it's all turned into something benign.
Yeah. And so so you're right that it's very far removed from some of the very practical engineering challenges that we're facing in other subtasks, because it's a very low TRL level, so they're really still developing at the nanoscale, let's say, these materials, and trying to scale up to be able to produce them in quantities that you need to be actually of some practical use in the inner environment. But at the same time, to justify this investment in producing those materials, you need to be able to show how they will be able to contribute.
Yeah.
And that is where they fit into the annex, because we wanted to make sure that our framework of assessing different technologies allows for this type of technology that will address one specific pollutant
Yeah, and
efficiently.
And you can understand the law. I think that there's a plain logic to that. You know, if I think if you understand what's important, which is kind of subtask 1, and where this stuff is coming from, it's equally important to know if there's something that can be there that can get rid of this stuff outside of the engineering control, the ventilation bit, which we'll come on to in a minute. But if there are sinks for these pollutants of interest, the net balance then is affected by that, so that they have huge potential. If you can have paints or materials or furnishings or whatever it is that are actively changing the net balance of our exposure before we then have to deal with them in the environment once they're there.
Exactly.
Yes, it's a fascinating subject. Not that I understood anything that I've read so far at all. But then I'm a chemist. But I did see, you know, I think when you see the practical implementation of it, these MOFs put into air cleaners and things like that, they can be incredibly effective at scrubbing particular things. Yeah.
And if you can tailor them to work specifically on
what
the priority pollutants,
that's the main difficulty. Yes.
Yeah, formaldehyde is a classic example of that. It isn't something that can necessarily just be ventilated away with increased ventilation. There are impacts of more ventilation on formaldehyde production, isn't there? So if there's a materials that can take it out, I guess they must have a similar impact. I mean, the formaldehyde's a funny one in that way, isn't it? That it tends to release more the less of it there is.
Yeah. So
always looking for equilibrium.
The hierarchy of controls.
Yeah.
Still, first remove the source if possible.
Yeah, exactly.
Then, if that's not possible, then it's good to have a range of alternative solutions that you can combine to provide you with the most energy efficient combination.
And then in this kind of logical sequence, then you get to the engineering controls, the ventilation, and I'm guessing, with a little bit of insider knowledge, that the point of ensuring performance of smart ventilation systems is that you're starting to say, well, okay, we know what's of interest, we know where it's coming from and how much and how to quantify it in modeling and so on. Can we now start to assess these various smart technologies in how effective they're going to be in these environments? Is that a kind of summary of Subtask 4 to some degree?
Yes and no, I would say. Yes, because of course it's what we would like and what we propose when we structure the project like that. But in reality, it's more complex because we have, how do you say that? We don't do first the ST1, then the first subtask, then the second one, and then we are working all together, and we have skills, complementary skills between the Subtask 1, the different subtasks, and Jelle, who manage the whole project, which is very efficient and interesting. So, for instance, in smart ventilation field, before the start of the Annex 86, we had already a knowledge about, in practice, what are the performance indicators which are used, and we cannot start from a blank page and say, okay, there is nothing, so we use the data from the ST1 with this Hertz metric, but we have to start with the reality, because as Jelle said, we are not talking about theoretical strategies which don't exist. Some of them already exist and are already assessed with existing rating schemes. So we tried during the annex to have like to feed the ST1 with the knowledge of ST4 on smart ventilation, and as well to use the output of the ST1 in the smart ventilation task.
Yeah, so
I don't know if I'm really clear.
No, I think
yeah,
that's very clear. It's less technology development because a lot of this technology and systems already exist out there.
It's both,
It's both,
because it's not fixed, and we hope that it will technologies. There are still innovations, and it will change in the future, and especially because such strategies are very old or common in some countries while they don't exist at all in other countries. So we have to consider that from an international point of view. But so they already exist, but in some countries they don't exist in other ones. So for new ones, maybe we can start from a white page and start with other metrics. But for the countries where it already exists, we have to consider to compare how the applicability of the new metrics or compare what we used before. At least we have maybe an intermediate period where we compare all these indicators and
yeah, interesting.
And at the end, we could say, okay, this one is really the best one, or maybe not. Maybe it is a very good one, but we have to keep some others. For instance, concerning humidity. So if we consider the health-based indicators developed and proposed in the first Subtask, and which should be used really soon in in the HRS standard, we don't think about a humidity management, while in many countries humidity management is the first purpose of the ventilation system. So we have to consider that, to my opinion and to the opinion of many experts. So that's how we work during the project. We don't have one unique answer. We have several proposals, and at the end of the project, we are on the way of taking maybe a final decision, but it's not done. We are still comparing,
but that's the value in this work, I guess, because at the end of the day, very often we're measuring proxies in a space, whether it's humidity or CO2 or something, we're not necessarily measuring the thing that we might have defined in the metrics part of this, but we want to understand, is using that proxy giving us the outcomes that we expect on the pollutants that we've defined as causing us harm, which I think is an interesting.
You can.
There's that. There's also how can we use the technological insight that was developed, for example, with measuring humidity and CO2, to now use this knowledge to include other pollutants like formaldehyde or PM in what we measure and how we control smart ventilation systems. Without making the same mistakes again, basically. So we're proposing new indicators, but we can also use what we learned.
And you can't buy that, because theoretically you can define an awful lot, but practically there has to be learning on the ground. So if there's existing technology that's already figured out that systems configured in this way don't work for another reason outside of the things that you're thinking of, that can be a hell of a dead end to find yourself going down. So having a range of technologies out there and approaches that are already walking the walk commercially on the coalface is quite helpful, because you're working with systems that have already found a way of selling into the market, so at some level they work. You're not innovating the core hardware necessarily. That's already being done. What you're looking at is their effectiveness, and how do we assess.
And what is effectiveness? Because one of the big works that Gael was working on also is, there's theoretical effectiveness during a simulation. Like, is this technology able to maintain a certain indoor air quality in this controlled environment, yes or no? But there's also, how does it work in practice, and how do you maintain that performance over time? And so what are the metrics and the procedures that you need to put in place to make sure that the technology keeps functioning.
Yeah.
So in the Subtasks, in our Subtasks, because I was working with Jakub Kolarek from the DT University, that is another point that we didn't say until then. Each Subtask is led by a leader, but we have a co-leader from 2 different countries, and this is really efficient as well, because we can learn from what happened at the same time during different countries. It helps a lot. And so in this Subtask, we first had a literature review on the performance of smart ventilation strategies in general in the literature. And we found, so as I said, hundreds of studies on different smart ventilation strategies is really not an emerging issue. Many research teams around the world are working on this topic in order to save energy in general. The first goal. And when they did this literature review, the colleagues, they really it was not possible to compare all this performance together, because in every studies they use different metrics, they use different input data for emission sources, they use different rating schemes, and that was really a good input for a good starting point for the work during the Annex 86, because we highlighted the need of a common rating scheme. And then we as well worked with what happened during the Annex in the different countries on the standardization and regulations concerning smart ventilation strategy. So in some countries, including France, during this period, we had major changes with performance-based approaches, so using some rating schemes. And finally, when they did that in France, for instance, they were asking us, in the Annex 86, what are you doing? What could be interesting for the national regulation and so on? But they say, okay, it's good, but they propose other things. And so after that, in the consortium of the Annex 86, we say, oh, it's interesting what happened in France. We could complete as well our framework with other indicators. So it's not an up and down approach or between the subtasks, but as well with the standardization and the regulations ongoing.
Yeah.
It's really...
Two questions sprung to mind there. One, it struck me, and I noted it earlier as well. Is this purely an academic endeavor, or does industry, policy, real estate, are there any other kind of public health, like in annexes, does it become multidisciplinary? Is it multidisciplinary? Should it be more multidisciplinary? I mean, these are big questions, I know, but I got the sense from talking to you that because of the nature of the needing people to spend time doing this work and research, it's going to inevitably, the heavy lifting is going to be done at an academic level or at an institute research type organization level. But are there other disciplines that get pulled into annexes?
There are, and that's the... When you go back to what annexes are, that's the eventual goal. The reason countries are interested as members of these annexes is because they're interested in what it provides them in terms of how they can improve their policy, their institutional settings to deal with these problems. There's an issue with the available resources, because, as you well know, doing the research is one thing, translating it into something practical is another thing, but then the implementation is a completely other ballpark. So there's only so much you can do within one 5-year period, and within a group that is struggling to mobilize the resources to be able to do it. But it is always the intention to have as much hooks as possible with adjacent fields, with people who are really into implementation. And like Gael was saying, there we've been lucky with her group and the group around Ben, for example, that they had connections with people that were more into standardization processes, for example, that they'll be able to translate what we were doing into those processes and therefore drive them forward. Something we haven't mentioned yet is the AIVC, which also technically is an annex, but of a different nature because it's set up as an information center and it functions for more than 40 years already. And that is one of the platforms that we heavily rely on within the annex to work towards dissemination, to build these contacts with policymakers and things like that.
Yeah. So that kind of goes to the outcomes of this, is that how's this disseminated and used and by who? So something like the AIVC is then a conduit for that to get it out to different organizations.
Yeah, and this is how we set it up from the beginning, because we knew that our resources within the annex would be limited. And so we partnered from the onset with AIVC as kind of the strategic partner to do the dissemination, do the networking, make sure that we have the connections to bring what we developed into the world.
Yeah.
And coming back to the industrial partners, some of them were involved in the Annex 86. We had some directly involved, but some of them were indirectly involved. So those national projects which support the intervention of research or experts in the Annex 86 were supported by industrial, or were in the consortium supported by national public agencies. There were some industrial, especially on the Subtask 4 with smart ventilation strategies. So we had in France this project Performance 2 with the long-term performance of humidity-based ventilation, which was a very which contribute a lot to the Annex 86 project. But in DTU, the same, they had another project, I think in Belgium, there was another project. So they were not always directly involved in the Annex 86 activities, but indirectly because we use data from project with them at the national levels.
And that was the same for you as well, Mark, wasn't it? I think you were able to leverage things like Renson data for the top-down approach. They had indoor air quality data from their
a huge amount of data.
Yeah. In fact, too much, I think.
Too much.
We
had to separate that to not bias.
Kind of affected the bias, But that's a good example. Good examples of both research in long-term effectiveness of products, in the performance project, and then that kind of live data.
And maybe it's good to also emphasize that they were not only involved as kind of suppliers of things, but also really directly involved in some of the discussions to make sure that we were aware of what their needs are, what they are looking for, to develop their products further, in terms of how they will be assessed, what they are optimizing for, basically.
That's a really good point, Jelle. And industry are always very keen. And as you know, I chair the industry advisory committee for the AIVC, and one of the things they point out regularly is that actually we have our own research organizations and people, and we have internal knowledge, and we want to share. That often industry is very hungry to share knowledge, so they're an enormous resource in the right circumstances. And knowing the animal that you're dealing with, being industry and everything that goes with that, but nonetheless, they can be an enormous resource, not just for support, but for knowledge.
Absolutely.
Some
and you were talking about the standardization, the European standardization. Many industries are take part in this standardization process, so they are really aware about these rating schemes that we are working on during the Annex 86. If they become part of the future standards, European standard or other standards, they are really concerned by that. So
you say ratings, so that'd be an interesting question to ask. What are some of the outputs going to be from this? Because I scribbled down here, have you been kind of pulled into this we need a rating scheme question? Like there's a hunger out there to label everything, right? Obviously.
Yes.
So I'm imagining this work has there been some pull to say, like, is there an output that I can stick a label on something ultimately and call it an A or a B or a something, a green or a red?
There definitely has. So we have some very practical outputs, like the databases that Mark was talking about, or how to assess the durability of a system, like I was looking at in the Performance 2 project. But the overarching output is, of course, how do you do this assessment? How do you do this rating? And I tried to address this question during the last AIVC workshop a couple of days ago, in a sense that I think talking about a rating scheme or an assessment method is maybe not setting up the right expectations for what we are doing. So I coined in a new word. Well, it's not a new word, but a different way of stating it, as a rating ecology, in a sense that what we are doing is trying to move all of the components in place for people that are doing rating in some way or another, that they're able to do it, so that they have all of the tools and the resources available to compare different solutions.
That's a really interesting idea. And I actually, when you were presenting, it was one of the things I scribbled down was ecology. I like that concept. Unpack that for me a little bit, right? Is this the idea that there's a lot of moving parts here, different standards, different ratings, different organizations, different silos. So rather than this coming up with a one thing, that this is a support mechanism in some way for the ecology, the grand ecology of understanding the performance of.
Yeah, if you look at it from a distance, I think the big move we're trying to make here is going from a very prescriptive approach to how to deal with indoor air quality. You need X amount of air coming from there, going to there, that's it, to a more performance-based approach where you put forward goals of what the indoor air quality management system needs to achieve as a practical outcome. And then you use this whole ecology of moving parts to help you assess whether it will be successful at that during design, during monitoring, during the different stages of its life.
They talked about that. One of the presentations from someone that was talking about the EN standards for air quality talked about kind of 3 levels and a 4th, I think, including infection risk. But this kind of idea of there's a kind of a basic threshold type performance. You've got aerolic or air movement performance. This is the kind of airflows. These are the kind of systems that will do X. And then an actual performance outcome. Is it hitting certain indoor air quality parameters? So that kind of idea sits very well, I guess, within how we're starting to view standards as a more of a smorgasbord of figuring out what's appropriate for the right building, rather than saying a label for everything.
Indeed, but the difficult part about this is that in that process of doing this assessment, there's a whole lot of choices that you need to make. For example, and your potential inputs or distributions. So you need to do some assumptions. You need to make assumptions on how things are going to work, how maintenance is going to affect the performance of systems, how occupants are going to behave in the building that you're looking at. There's lots of assumptions, and this ecology that we were talking about is the definition of an ecology is different organisms that interact with each other and create an environment that allows them to flourish, basically, or die off, but hopefully flourish. And so what we're trying to create in this paradigm of performance-based assessment is all of the tools and connections that people need to be able to justify which choices they make, to have the tools to make these choices, and therefore create an environment in which designers, policymakers, manufacturers can position themselves and have a meaningful conversation with all of the other actors in the ecosystem, and therefore make the whole thing more successful.
Yeah, that's interesting. And that kind of goes on to that question, like, who's this for? Like, when you kind of imagine the users of this information, I mean, I guess your hope is that this isn't just another report on a dusty shelf in the International Energy Agency somewhere in Paris.
No.
Right.
That's the short answer.
No, right. Well, maybe I'll ask that of all three of you, of the work that you've done. Maybe I'll start with you, Mark. Like, a database is a great tool for people to use. Like, who in your mind would ultimately kind of start accessing this information and using it?
It's basically accumulators first.
Yeah,
we need that for the input, but also to make the standard, for example, you need this kind of inputs also to define some levels of emissions from the materials or occupancy. So for me, it's this kind of people that will use that. There's no...
So people that might be defining standards over times, or national regulations, or engineers that are looking at big problems, they've got a resource that they can mine and come to some conclusions from. Very interesting. What about you, Gael? Like, the work that you've done and a lot of this kind of comparison work and looking at different systems and how they perform in different circumstances, that's as an output. Do you see people using that in some ways, like a design tool, for example, or to ratings methodology, or do you get a sense that it will find a use with the group?
I think it's really, it could be for different for different type of actors. Part of the work is really useful. I hope it's really useful for, but we already talked about that, for decision makers and people involved in regulations and standardization, because they need assessment methods for new buildings, for the ventilation installed in new buildings. What we have to precise maybe is that in some countries you have a global regulation for the building performance, and building performance will include energy, life cycle analysis, and other parameters like EAQ. But in some other countries, which is the case in France, you have one regulation for energy performance and you have another one for ventilation. And so what we did during the Annex 86 could be directly used in some country where they have a regulation for ventilation only, and if they want to make it more because most of these regulations are prescriptive with fixed airflows, and if they want to allow innovative systems like smart systems, they have to change their regulation. So they could use this type of assessment method that we developed. So first. Secondly, manufacturers, industrial partners, if they want to be aware of what is going to be done in some countries and they want to have new market opportunity, they could have a look to these schemes and to identify how different they are from the one they already knows, and they could anticipate future in general. And identify market opportunity because, for instance, the influence of weather it could be important of climate, I would say. So using this scheme, they could identify where their products are more effective. And finally, Jelle already spoke about the real performance of systems once they are in operation in real buildings. And so we try as well to work on inspection protocols to point out the importance of maintenance as well and the role of occupants. And so for all these actors involved in the real life of building and the real life of ventilation system, we have interesting outputs.
And I guess there's an enormous amount of feedback loop potential here that as people understand this and they get more data, it feeds more back into your database, Mark. That database enriches the emissions and exposure risks, so you understand more deeply for the, it's as an ecology, it's a good analogy for that, is that it becomes a self, what's the word I'm looking for? Propelling system in a lot of ways.
Mm-hmm.
Yeah.
And that where doing this type of assessment, like modeling a building in detail, trying to come up with all of the input data for all of the indoor sources, doing an assessment of how this will affect the occupants, until a couple of years ago when we were all doing our PhDs, was PhD level work. It's now moved into something that specialized engineering firms can do for you commercially, and the framework that we're trying to build pushes towards making it available even more downstream and more and more building projects, basically.
Create this kind of trickle down effect into industry. Yeah. And what's your hope, Jelle, as a whole for this? Is it? I mean, I know there's already discussions about what 86.23 might look like. As with all of this stuff, you're always thinking what would next look like. But as a product in of itself, what would your hope be for it? Is it around this ecology thing ultimately, that it becomes a self-propelling ecology of tools?
Yeah, I think if we are able to put the things on the table that allow this penetration of a performance-based approach in everyday practice in buildings, that would be for me the ultimate goal. And as you were saying, we're thinking about what's the next big challenge then, and it's of course implementation through standards, through making sure that the practitioners have access to this. And a big challenge, but also a big opportunity for that is in the renovation wave that is going to happen over the next years and decades, where not only will we need to be able to do this in a process where we're designing a building from scratch, but we need to be able to go into an existing building, understand what is going on, where the potential pitfalls and problems are in the building, and then propose a solution to move this from quality level X to a higher level, like level C or whatever you want to call it.
Yeah.
And then so this requires another layer of more practical, available tools to estimate what is going on.
Yeah. No, it sounds absolutely fascinating, and I can't thank the three of you enough for spending time with this afternoon. For listeners, this is the end of a very long week of board meetings, workshops, and annex meetings. So my three guests are as frazzled as they probably can be for a podcast. So incredibly brave for sitting in front. I fed them caffeine, to get them going. Thanks for listening. Before you go, can I ask a favour? If you enjoyed the podcast and know somebody else who might be interested, do spread the word and let's keep building this community. This podcast was brought to you in partnership with Erico, ACO, Ultra Protect, Imbiot and 21 Degrees, all great companies who share the vision of the podcast and aren't here by accident. Your support of them helps them support this show. Do check them out in the links and in the show notes and at airqualitymatters.net. And don't forget to check out the YouTube channel by the same name, with plenty more content due to come on that channel. Thanks very much. See you next week.